When reviewing information, it is important to understand when the information may not be accurate. Information in the form of statistics collected from data can be misleading for several reasons. To be considered valid, the data collection process must not be biased. This process may lead to a biased sample that creates misleading statistics. Data points form patterns. Points far from other observations are considered outliers and can disrupt the analysis process. Tools such as graphs and charts are often used when reporting data. When used improperly, these tools can also make data misleading. Using data that are incomplete is another leading cause of misleading statistics. After considering all necessary factors, the conclusions formed should be accurate and well supported. Consider the following example regarding the collection of a sample. A cookie company wants to call their chocolate chip cookie America's favorite. They develop a taste test and set out to collect data to support a conclusion in favor of their product being America's favorite. Employees of the company were dispatched to food stores throughout the country to conduct these taste tests. Customers were enlisted to taste cookies and report their preference. Data were collected and brought to the company for consideration. The results of the taste test were reported, and the company's chocolate chip cookie was the winner. For a sample to be valid, special consideration needs to be given to the process of data collection. Was it a surprise that the cookie company arrived at the conclusion they set out for? Let's look at some facts. The company could now report their chocolate chip cookie as America's favorite, and they had the data to support this conclusion. However, the taste test was biased at every step. A biased sample can corrupt the results of every step to follow and cause misleading statistics. An outside vendor should have been employed, even at the risk of an alternate conclusion. So all in all, this sample is biased. Let's look at another example. Johnny is a student with a driver's license and is allowed to use the family car with permission. As long as he maintains a B average in math, he will be allowed to use the car. Johnny wants to drive to a basketball game on Saturday night. He decides to ask for the car during dinner on Wednesday night. He starts by reporting that he has met the required B average in math because his test scores are around 90. On Friday night, his progress reports arrive at the house providing his specific math test grades: 95, 91, 88, 83, and 43. Reviewing the data reveals one test grade of 43, a test score outside the overall pattern of distribution, an outlier. Johnny meets the required B average even when including the outlier, but this average doesn't accurately reflect his progress in class. The progress report has made his parents rethink the original analysis of the data and the decision to allow Johnny use of the car on Saturday. A data point that lies outside the overall pattern of a distribution is an outlier. An outlier can be an anomaly or even a mistake in the data, or it can be an indicative of something else happening. So, this data is misleading due to an outlier. Let's look at one more example. Hospitals are expected to provide complete and specialized treatment to address the healthcare issues we present in our greatest hour of need. Unfortunately, hospitals are not always successful when treating a life-threatening illness. A great deal of resources have been allocated to the documentation and analysis of treatment results. Data are collected, and reports indicate that a greater number of patients die at large hospitals than at small hospitals. These data lead to the conclusion that the quality of care at small hospitals is superior to the treatment received at large hospitals. A conclusion such as this tarnishes the reputation of all large hospitals. It is normal to have high expectations for our hospitals since they support our survival. The personnel providing our health care are expected to follow established procedures and complete documentation necessary for tracking the results. The data may be misleading for several reasons. Most large hospitals can be found in or around large suburban areas, since that is where the need for healthcare is greatest. Large hospitals serve a large population, so logically a greater number of deaths will occur. In general, large hospitals also have a greater number of patients. With a higher number of patients, there can result in a higher number of deaths. The level of care provided at a hospital is not related to the number of deaths, and the conclusion that small hospitals provide better care is inaccurate. The outcome of data analysis is typically a well-supported conclusion. Missing or inaccurate data can result in a false conclusion. This example involves an inaccurate conclusion.